Perfect, awesome. Well, welcome everyone. Thanks for coming along. I appreciate this session has got a lot of good talks in, so if I wasn't presenting, I would totally be next door, I'll be honest, yeah. But thank you for coming along, I appreciate it very much. So we are going to be looking at how to create a cloud-native, an effective cloud-native developer experience. Starting from first principles, always like to remind myself, the reason we're in this business, I'm assuming most of us are engineers, QA, architects, that kind of thing. We have an idea, and we are trying to deliver value to customers. Yeah? That value can be monetary sometimes, but it can also be, if you're working, say, for NGOs or charities, it can be many other things. But you're trying to deliver some form of value. Have an idea, deliver value to customers, to end users. Many of us in this room write, build, deploy, test software to do that. If you can deliver value without writing software, great, because there tends to be less bugs with less software. Yeah? But the reality is many of us, this is kind of my generation, I started coding back in the DOS days. These days, we very much deploy our apps and operate them via the web. And cloud native, kind of a bit of a buzzword, but things like containers, things like Kubernetes are kind of where it's at, yeah. Kubernetes pretty much won the container orchestration wars between Mesos and Docker and these things. And I'm going to focus on sort of some of the Kubernetes things today. But regardless of what kind of cloud-native platform you're building, you're running on, hopefully many of my lessons and many of my mistakes I'm going to share will resonate. Now, the challenging thing with building software and running it, say, in the cloud, is this thing in the middle. Yeah, this kind of like this testing, this integration testing, this debugging things. That is the hard thing. We all recognize good developer experience. When stuff goes well, we package it, we ship it, customers happy, great. I'm sure many of you recognize that promising tool that you fired up, and it didn't quite work as expected in the cloud, yeah? Anyone who's used the AWS consoles for things like CloudWatch, you know the slightly wonky experience with that. Not such a good look. And the worst thing you can get in my experience with, like, in relation to developer experience is when you push to prod and it falls over, and you've got no idea what's going on. You can't understand what the system's doing, and there's multiple layers there, where's the issue? This, for me, this kind of thing in the middle here is very much what I'm calling developer experience. And that's what we're going to be focusing on today. How do you create an effective experience for us as developers, us as engineers, us as QA, when we are operating on the cloud? That's the key thing. This is me at Daniel Bryant UK on the Twitters, on GitHub, on LinkedIn. I've pretty much cornered the internet world with Daniel Bryant UK. I'm a freelance consultant, primarily working out of the UK, but I spend a lot of my time with a Boston-based company from the US called DataWire. And we do the Ambassador API Gateway, telepresence, if anyone's used the debugging tool, telepresence. I'll briefly intro those. Not here for the sales pitch by any means, though. My background, very much a sort of academic start, did some consultancy, some startups. I've made many mistakes, to be honest, and had a few successes. So I'm hoping to share some of my learnings along the way. Breaking it down to first principles, Developer Experience 101. Now, I first bumped into this sort of new term, and we do love a good buzzword in our industry, DevEx, from a gent called Adrian Treneman. And it was actually at, I think, QCon New York a couple of years ago. And he said developer experience is about reducing friction between creating a hypothesis to delivering an observable experiment or business value in production. And that totally resonated with me at the time, like this notion of friction. I just got into Docker, kind of heavy, and compared to my Java days where I was building monoliths and it was quite a nice developer experience, when I suddenly have to start putting stuff in a container and like that docker.build kind of, docker build, -t dot cycle, suddenly I added a lot of friction into my workflow. That's when I kind of got interested in this space. I wrote up some Adrian's notes, fantastic talk he gave. I put some stuff up on InfoQ, so I'll share the deck later. You can pop along and read more about Adrian's thinking there. Now, it's not a new concept by any meaning. Developer experience, I hope this book gets shared a lot at this conference, but we've been talking about developer experience like literally since coding began, back in the 60s, back in the 70s. But it's become more prevalent in relation to things like DevOps. And Nicole Forsgren is doing fantastic work, so the state of DevOps reports, these things. And I want to pick out, like she and her team identified 4 metrics for high-performing organizations. Now, if you minimize your lead time, you optimize deployment frequency, reduce your mean time to restore if something goes wrong, and change fail percentage, keep that low, The book goes into a lot more detail, but basically those 4 indicators correlate with high-performing organizations. So they are the leading kind of indicators. If you get these right, your organization is going to be high-performing. Now, in my mind, at least 3 of them, the top 3, are directly related to developer experience. Yeah? Can I quickly get stuff from idea to code along my pipeline in production? Can I understand what's going on? Deployment frequency, same deal. Mean time to restore. Well, I've got to understand what's going on or have some kind of automation in there to restore. Yeah? So for me, like this kind of stuff, Nicole, Jez, Gene Kim, talking about this kind of stuff for a long time. And even like Martin Fowler. I was really quite enamored with this blog post when it came out. Martin's stuff is generally pretty awesome. But when he started talking about the prerequisites for microservices, yeah, you need to be this tall to use microservices. And again, 2 of these things, basic monitoring and rapid app deployment, for me, are key to this developer experience. Yeah, if there's more friction, this stuff takes longer. And it makes deploying distributed systems, because let's face it, if we're deploying in the cloud, it's inherently a distributed system, because even the block stores are going over the network. Yeah, even if you're deploying a monolith, there's some kind of network involved there. Most likely you're going to be using microservices in the cloud. Everything kind of changes. I love reading books. Anyone who's come to my talks before will notice like I do recommend a lot of books, and I like to share my thinking with you to kind of give you a background if you want to go into more depth. My 3 references for what DevEx is: the DevOps Handbook is a fantastic book, particularly if you're working in a big organization looking to embrace things like Lean, like DevOps. Lean software and intentionally creating good UX. And the reason I bring these 3 books up is a lot of developer experience is about creating fast feedback. We've got a business idea, we want to code it, test it, get it out there as fast as possible. And we want to not only create this kind of very fast feedback loop and recognize we're dealing with a bigger system, but we also want to optimize to create a culture of continual improvement. Yeah, continually learning stuff, sharing it with our team. That's what the kind of DevOps stuff for me is all about. Lean is about minimizing waste. Definitely for me, the Docker build cycle was really painful. That was an obvious one. But there's many other things I'm sure you can all think about in your daily jobs where what you kind of do is wasteful. Yeah, and you haven't got the time, is the kind of ironic thing. You haven't got the time to fix the thing to be less wasteful, take less time. And we spend a lot of time getting the UX of our customer systems really good. But the tools that we all use day in, day out, bar some of the really polished IDEs, a lot of the other tools, the UX is generally very poor. Yeah, and I point to Amazon way too much. Amazon are awesome, I use them all the time. But like the AWS console is a classic example of this. Like it's clearly evolved over time, and it's hard to work with sometimes, yeah? And I have learned a lot by chatting to my UX colleagues, reading around UX, and understanding that a little bit of investment up front in the way we design our internal tools pays off big time further down the stream. Yeah? If we think about how this CLI tool is going to be used, think about the visuals we need back, we can actually save a lot of time by investing a bit of time up front. So in terms of how developer experience relates to kind of workflows from idea to value, platforms is key. And to be honest, this talk is a little bit of a platform rant against Kubernetes, which I'll go into more detail in a moment. But I want to give a little bit of background. Like I started my career working with Waterfall. I worked for the UK government. They gave us fat documents, boom, and we had to turn those documents into code using Java and the monolith at the time. We moved on to what I like to call mini Waterfall, or Agile, as the kids are calling it these days. But it's kind of the same thing as Waterfall, but we're doing it more incrementally. We're doing it faster. It's a good thing, of course, but nearly everyone is Agile these days, even when they're not. Yeah. I think we're seeing some companies move on even more from this. Like the Netflix team talk about full life cycle developers. People that are business savvy, like us, but can also code. Yeah? And I think this is a really interesting idea. DataWire, we're talking about the same kind of thing. We want to give tools to enable people that have a business idea and can work very closely with the end users to deliver value really quickly and optimize in this loop. Now, some folks, James, the governor from Redmonk in the UK, have talked about this as a kind of progressive delivery. Again, we love our buzzwords in the industry, and someone's rightly kicked back and just said, isn't this continuous delivery with a new name? Yeah, it kind of is. But James is a deep thinker. And one of the things James said is to do this kind of enablement for people having ideas to delivering value in kind of modern applications on the cloud is we need to augment the platform to support some of the tools. So I'm sure many of you have heard things about Canary testing, rolling out, say, a new bit of your application, but only putting 1% of traffic there, seeing what happens. If it's good, we roll the Canary out more, 10% traffic, 25, 50. And also things like feature flags, same kind of thing. We turn functionality on. Is it good? Awesome. If it's not, we turn the functionality off. We clearly separate deploy and release. They're the key things. And that's what progressive delivery captures. There is a flip side to progressive delivery, though, and James goes into this more in the article, but it's something I saw Stefan Tilkov talk about, I think it was 2 years ago now at MicroExchange in Berlin. He had a great presentation, totally recommend watching it on YouTube, about microservice patterns and anti-patterns. Now, we all recognize the good things of microservices is, we can run these autonomous, like 2 pizza teams, all good stuff. Now, I worked on a couple of projects in this kind of space, and we definitely saw this advantage, but we also saw the anti-pattern to this, which is the micro-platform. So we had like an app that was Ruby on Rails monolith, and we were putting in Java microservices, Ruby microservices, and Go microservices. We were deliberately, it was a business goal for friction kind of reasons, we wanted to break the monolith up. This is like circa 2014, I think, so not all the cool tools were available to us at the time, but we really struggled with building in some of this functionality, and we had a Java implementation of service discovery, a Ruby implementation of service discovery. We were doing circuit breaking, and the Hystrix we were using in Java was fantastic. The Hystrix we were using in Ruby had been written by one person over a weekend in their bedroom, and it was like on GitHub for free, and like we used it, and it was proper janky. Yeah. So we built a platform in each of the languages. We were trying to do canarying in Java, canarying in Ruby, and they were subtly different libraries because we were doing it actually in the app, and it was a nightmare. What you really want to do is support some kind of centralized platform. Yeah, you want to, all the teams want to be operating independently around the edge, but you want to provide some notion of a platform that gives you, or gives the engineers the ability to kind of self-serve. We want to roll this out gradually. We perhaps want some kind of SMEs, we want some kind of subject matter experts to give us advice. Apologies for the resolution. My laptop's being a bit funny. I will share the slides later on. But we want to enable these teams around the edge that are maybe going at different speeds. Some are prototyping, some are coming up with ideas, some may be in sort of production code phase, and some may be like running our crown jewels, like they may be running mission-critical systems. So we want to create this platform and give like the various infrastructure to support these more modern ways of working, things like canarying, and things like resilience at our communication layer, but we want to be able to allow people to self-serve based on their needs. Now, one interesting sort of corollary of that is I always have to quote Kelsey Hightower. Kelsey is a deep thinker in the container space, and every time I do a container talk, I have to quote Kelsey. But he says, I'm convinced that the majority of people managing infrastructure just want a platform as a service. The only requirement, it has to be built by them. Yes, they want Heroku, they want a cloud foundry, but they have to build it themselves. And I've totally done this by mistake. Yeah. We start off with good intentions. We maybe don't think up front about exactly what we want, and therefore we end up building a Heroku. We end up building a cloud foundry, and we don't do it as well as those people, yeah, which is kind of interesting. Now, Kelsey makes a good point and says, there's nothing, and apologies again for the resolution, but that tweet says there's nothing wrong with building a platform. You probably, if you're using Kubernetes, you will have to build something on top, because it is not a full PaaS. But we need to recognize when we're building a platform and sort of trade off. Can we buy some of this technology in? Can we maybe look at some open source solutions out there? We need to recognize when we're working on bits of the platform that don't directly offer, give business value, if you like. Do we recognize the trade-off of they're going to cost us some money, but are they going to help us in the future by reducing friction? Yeah. And I don't know if anyone's fantastic book about building their own toaster. Has anyone bumped into this before? This is one person's quest where they wanted to build a toaster from first principles. Literally go and get the metal, hammer it together. Like they raised cows to get the milk for they were going to do butter on their toast. They kind of grew wheat. Basically, they tried to go as first principle as possible. And it took him, I think, 18 months to build this toaster, thousands of dollars or whatever, and he turned it on, and it caught on fire within 5 seconds. But the point being is, like, and it's a fantastic story about like one person's quest to what we all take for granted. We all go to a local store, we buy a toaster, we plug it in. But the reality is, many of us are building platforms in the same kind of fashion. Yeah, and I speak from experience, yeah? Yeah, so check out the book, it's worth reading. But there is some success stories I wanted to share. So Netflix, I know we're all not Netflix, but they really invested in creating what they called the paved road. Like Netflix are famous for their freedom and responsibility culture. You can kind of do what you like, but you're responsible, you're on call. But even they recognize there is some value in centralizing a platform. And they've incrementally built this platform out, the paved road. There is an escape hatch. You can totally go off the paved road, but then you lose things, all the tools they've created. They offer SLAs with their platform internally in teams. Like, you're on your own if you do this kind of thing. You can totally do it, but you're on your own. I found it really interesting with Netflix, with their very kind of freedom mindset. Even they were saying we need some kind of centralized platform. I learned a lot from Nico Curti, last year, I think it was, in QCon New York. And Nico has moved, but he was an engineer at Shopify. And they do e-commerce kind of as a service. So you can buy a shop, an online shop from them. And they were using Heroku, but it wasn't scaling. They were doing so well, Heroku for them was an amazing developer experience, but it technically was not scaling in some use cases. They worked with Heroku, and it was just like, we've got to do something different. So he and his team worked really closely with the developers, and they built a platform on top of Kubernetes. But they hid Kubernetes from the developers on purpose and with their consent, and they exposed a Heroku-like workflow on top of Kubernetes. So developers would literally just coding away, git push, and it would automatically roll down a pipeline and deploy into a Kubernetes cluster. They never saw kubectl, yeah? And when I was last chatting to Nico, they were thinking about creating an escape hatch, but Nico had sat down with his dev team and said, what do you like about Heroku? And they listed off all these cool things that, as developers, they just wanted to code. They didn't want to care about containers. They didn't want to care about all this operational stuff. They knew it was important. They knew they had to work with Nico and his team, but Nico had really curated this good developer experience based on what his engineers wanted, yeah, which I thought was a really powerful message. I've worked on a few big platforms in other companies where the teams building the platforms never talked to the developers, and that turned out very badly, if I'm being honest. So one of the key questions I'm going to look at over the next sort of 20 minutes or so is kind of questions for you. Should you build a platform? And I'm going to look at Kubernetes, but take your pick. Should you build a platform on Lambda? Should you build a platform on Docker Swarm? These kind of things, yeah. Now, some fundamental questions. If you answer no to any of these, do you understand your domain? Is the problem domain complex? Do you have product market fit? Probably best not to start building a platform, yeah. Go with monolith. Chuck it in a container, chuck it on App Engine, chuck it on Heroku. This probably seems really obvious to yourselves, but so many companies I've consulted to have been like, we'll build out this amazing Kubernetes thing, and then we'll put the app on top. If you've not got product market fit, that's probably not the right thing to do. If your solution is event-driven and quite simple, or you know in the company you've got bigger fires to fight, you've got to be adding value elsewhere, again, serverless is really interesting, yeah, as a kind of paradigm. And this is the best joke in the deck, I'll add, yeah, for serverless. So this kind of stuff is actually really valuable. I've played around with Lambda a whole bunch. I like it. It's not for every use case, but you can deploy code very quickly. You can look for product market fit very quickly. I really do like App Engine. I keep mentioning App Engine. I think if it's a Java developer, it's got a nice interface with it. And I don't need to think about a lot of the operational stuff if I'm just building a product to explore a business use case. Yeah, Elastic Beanstalk, Heroku, same kind of deal. I was in London at Continuous Lifecycle London a few weeks ago, and Matthew Skelton, definitely worth checking out Matthew's books, said this amazing thing. We're all familiar, hopefully, with the minimum viable product. Particularly if you're in an entrepreneur or a startup, you're always looking for this minimum viable product. And Matthew said something about the thinnest viable platform. If you can get away with stitching a couple of AWS services together, stick with that. And I thought this concept was really powerful. Always aim to minimize the kind of platform, to give functionality you need in your current use case, but no more. I've seen many companies, and I've been involved in a few, where we've massively over-engineered our efforts up front. And I think there's definitely value in curating developer experience, but know when to pick the right time. So if you are going to go for something like Kubernetes or a platform, I actually do really like Kubernetes. Yeah, I mean, it's sort of become the de facto container orchestrator as a service. All the clouds offer hosted options. You don't want to run your own Kubernetes cluster yourself unless you are really special. And even if you think you're special, I definitely double-check your use case, because 9 times out of 10, probably not. I think Kubernetes is really nice for building a platform on. Once you've got your product market fit, once you're at a certain scale, it's a good choice. What I would say is know the extension points within the framework. You get things like services and other concepts like that, and say pods, things like that. But I've seen some folks try to incorrectly build on top of the platform, trying to build an experience. And things like CRDs, we call them custom resources and custom resource definitions. If you're looking to automate something that a human would do as part of your system, as part of your operations of the system, exploring more about CRDs and operators are the way to go. Red Hat have got this thing called operators, and they offer an operator SDK. It's a real nice interface. You can build, it's typically Go. You write, say, some control stuff in Go. I did see just this morning the Container Solutions crew have released a first version of a Java operator SDK, which I thought was super interesting. So hat tip to Container Solutions, again. But this is the way, if you want to automate, like, say, deployment of things like Redis, things like Kafka in a Kubernetes cluster, probably you might want to look at your cloud hosted options first, but if you really want to operate this stuff in Kubernetes, check out Red Hat's operatorhub.io. They offer a bunch of pre-packaged operators that extend Kubernetes, and like the operators act as sort of automated humans to make sure Redis stays up, make sure Redis is consistent when a volume dies, or things like this. I've also got a hat tip. I think it's Adrian from Admiralty. He goes into a lot more detail on this blog post about why he chose to write operators for the Ambassador API Gateway, which is what I work on. I learned a bunch from Adrian on this one, and a couple of screenshots for you there. Nico also, in his KubeCon talk, they had created something slightly different, using custom resources and some controllers. It wasn't actually operators. They called them cloud buddies, and it enabled their engineers to use YAML to define very simple things, and Kubernetes would look after, like I think they could define, say, memory usage, various uptime things, and the operators would translate this very simple language that the developers used into some kind of automated process behind the scenes. So Nico and his team really leveraged this kind of technology as well. A good example of an operator, and I'm going to also use it to talk about sort of a couple of other things, is Flux from the Weaveworks team. If you want to understand how operators can add value, Flux is basically a continuous delivery tool. Something called GitOps, which is really popular. I heard Nikki talk about it this morning as well. Like, GitOps is a really nice way, particularly in the kind of Kubernetes mindset, of declaring what you want to happen and then it happening automatically. So GitOps is fundamentally storing all your configuration, how your services talk to each other, what the kind of runtime properties of those things are. You store all those configurations typically in a YAML file in Git, and then Flux sits somewhere, and it looks at your Git repo and makes sure production is in the same state. And if you change your Git config to roll out a new version of the app, or Canary, or whatever, Flux will recognize the change and update production. But also, if production goes down or some subtle bug creeps in, kind of like the config drift creeps in, Flux will again go, oh, production is not like the declaration. It will then kill that pod and restart things. So it's a great way to keep your declaration of what you want running in production actually matching production too. And it's a real nice demonstration of how to build an operator in Kubernetes. Moving on, so I mentioned this before, so how quick do you need feedback? So I'm sure developers in the room can totally recognize the kind of the inner dev loop when you're doing TDD, maybe you're mocking out things, you're stubbing, and then when you've got like some kind of something you want to share, you might do a PR, for example. But the inner loop, I found when I started using containers, and this is courtesy of the Microsoft site, the dev loop got crazy long. Sometimes I just needed to put something in a container and check it worked well with other things, and then Docker build, Docker push, check things worked. Like, this was a real point of friction for me. Yeah. Now, there are tools I want to highlight popping up in this space. A hat tip to Shahid, fantastic blog on the left, and Matt Farina talks a lot about, if you're more of an operator type person and you're trying to understand your kind of traditional world of DEBs and RPMs, Ansible, Terraform, if you're trying to understand how this maps to the Kubernetes world, these blog posts are great jumping off points to understand how you can automate that kind of container build in the background, how you can automate deployment of applications, how you can manage deployment of applications. Helm is really powerful as an example, but Matt talks in great detail about how to effectively use tools around Helm to get the best value out of it. I've got a few examples here. Again, this is more for your reference later on. You can look at these things. On the left, there's some tools to automate that in a dev loop, so it kind of builds containers in the background. You can run tests in the background. On the right, there's some more packaging tools and debug tools, which I'll go into one of them now in a little more depth. Because one of the questions I often get asked when I'm working with customers in Kubernetes is, how do I want to test? Yeah. When I get to a certain point of integration testing, maybe I physically cannot spin up all the services on my laptop. I love Java, it's my native language, as I say, but Java, its heap requirements are quite big, so you can typically only get a few services on a laptop. If you're trying to do an integration kind of test, you might need to spin up a remote cluster just to see if stuff works. Now, you obviously want to minimize that. Yeah, I'm talking sort of loose coupling, high cohesion, mock as much as you can and stay local as much as you can. If you've defined good APIs between your services and you've got good contracts, you should be able to stay local for as much as possible. And that dev loop is much faster locally. But sometimes you do need to go and integrate kind of with a bigger system. Yeah, and I'll share the graph later on, but there's kind of a spectrum of working locally all the way through to kind of coding in the cluster itself. Now, obviously, if you work locally, you're not spending money on a Kubernetes cluster either, which is good. But sometimes systems are simply too big. And there's a couple of tools I wanted to point out. One is Telepresence. It is a CNCF open source hosted tool. DataWire did create it, but we have donated it now, so we're kind of stewards in this space. There's also Squash, which is a similar tool for basically putting your laptop in a remote cluster. So you're running a remote cluster with all your, maybe a staging cluster, and you can literally swap out a service running remotely, locally. And you can run all your debug tools locally, like IntelliJ or some kind of debugger, and it's like your machine is actually in the cluster. So I found that really useful. And I'm going to shout out Cesar did a fantastic talk at DevEx UK a few weeks ago, a month ago, and that talks about his use of telepresence. And you can see there he's got a load balancer at the top. Some traffic, say, would come in there, and there was 3 services that were actually giving the functionality of his application. And he couldn't spin them all up on his local laptop, but he wanted to debug service B. There was something weird going on there. So he used telepresence to literally swap out that deployment, and it puts a two-way proxy in its place. So the service gets swapped out, two-way proxy goes in, you can spin up the local version of your service, and it's now like your service is actually in the cluster, but it's on your laptop. So you can run your debugger. You can do all command line, you can do NS lookup and digs and these kind of things. It's like your laptop is literally in the cluster. And this is a nice tool, I found. These kind of tools are nice for when you're trying to do integration testing in a remote cluster. Just a little aside I want to get people thinking about. I've noticed the kind of spectrum popping up in the world of innovation in this space. There's kind of on one side, it's bringing the cloud to you. Things like telepresence are enabling me to put my laptop kind of in the cloud. But there's a definite push in the industry, particularly by the cloud vendors, which totally makes sense, to move our development into the cloud. We may have just a dumb terminal, maybe like an iPad or something, and we're running everything else in the cloud. So Amazon have got SAM Local, if you're doing serverless stuff, like SAM Local, they've got a whole VM that you can spin up and do all your tests, all your development in the cloud. And Red Hat are looking at Eclipse Chi, so you can do Java development in the cloud. So this is an interesting thinking point. I wanted to perhaps have a chat with a few folks afterwards. I'm not sure where this is going. Do I see myself in the future running a very light laptop and doing all my coding in the cloud? It might make coordination easier with fellow developers if we're all in the same kind of space. But it feels a bit weird as well. So I thought it was an interesting thinking point. Changing tack. So how do you want to verify your system? So you're building this cloud-native system, probably distributed microservices. I'm not sure if people are familiar with Cindy Sridharan's work. She's Copy Construct on Twitter, Copy Construct on Medium. And one thing I've learned a lot from Cindy, but one thing in particular was her discussion around the testing pyramid. So hopefully people are sort of generally familiar with the testing pyramid. You have sort of like unit tests on the bottom all the way up to manual tests. And the initial model with the testing pyramid was that you invest in more unit tests because they're easier to write, cheaper to run. But all the tests in this pyramid have value, but you want less user-driven tests at the top because it takes a long time and they're expensive to create. Cindy's arguing, though, that in complex distributed systems, which we're pretty much all building in the cloud, you're dealing with complex systems, and there's only a probabilistic guarantee of correctness. Now, Cindy is not arguing that you abandon pre-production testing, quite the opposite. She's saying all the kind of classic stuff we know and love, testing in dev, pre-production testing, keep doing that, but the testing pyramid is probably a bit wrong for all these complex cloud-native systems we're building. Cindy's arguing that we need a test funnel, and we need to be testing more in production. And we are seeing things like chaos engineering popping up. And chaos engineering is kind of testing the codification of your cross-functional requirements in production. If you think your system can survive one service dying or there being increased latency in the data store, you can codify a test with chaos engineering, have a hypothesis, test the hypothesis, and see how your system behaves. And I think there's a lot of value in doing that because there's only so much correctness you can guarantee without deploying a cloud-native app actually into the cloud. As simple as this sounds, her blog post is amazing. I learned so much from it. Skipping on. Nope. Slight aside, shameless plug, I did a talk with my co-author on a book, Abraham Marin-Perez, about testing Java microservices. So if you do want to know more about my thoughts and Abraham's thoughts on how to minimize the need to involve the platform, we've talked a whole bunch. It is slightly Java-themed, but we talked a whole bunch about our learnings, our mistakes on testing microservices. So that's a slight separate topic. I wanted to put that link up there. But back to the main kind of thing. The pitch here really is, like I mentioned up front, things like canarying, rolling out 1% of traffic, observing what's going on, rolling out more, is really valuable. But to do that kind of thing, as like, say, Etsy do, as Netflix invested quite a lot, you need other tools. And again, hat tip to Weaveworks, fantastic tool called Flagger. Flagger works in combination with something called Istio, which is a service mesh, which is kind of another buzzword in the cloud-native space. There's lots of things popping up sort of in the cloud-native platform. I'm sure they will all get pushed down at one point, but at the moment we've kind of got all these different things floating around. But if you are in the innovator space, if you are building a platform, you definitely need to be aware of things like service meshes. And Flagger is an operator, effectively, to automate canarying. So you can say, roll out, like you deploy your two services, V1, V2, and you can declaratively specify, can the system increment the real production traffic from, say, 1% to 10% over 10 minutes. And you can also define failure cases. So if, say, like 503s, HTTP 503s errors spike, you roll the system back. You have two things in production, but you divert all the traffic back to your V1. It's a real nice way to automate the rolling out of, and basically looking at key metrics. They can also be business metrics, in addition to platform metrics. If you're rolling out a service, you're putting more and more traffic onto it, away from V1 to V2, something's going wrong, Flagger will automatically roll it back for you, which is quite nice. A lot of these things do use things like HTTP headers. So maybe you're only canarying traffic based on traffic from the Netherlands, or maybe you're only canarying traffic based on, say, iPhone users. So you need to understand, or your networking gear in the cloud needs to understand the layer 7 of, if you think about the OSI stack, layer 7 is application level. Your networking stuff, like Flagger, needs to understand things like HTTP, needs to understand things like Kafka or Mongo, to understand the protocol to make the right decisions of where to route traffic. So there is a very popular framework. Istio builds on top of it. It's called Envoy. It's basically just a proxy, like Nginx, like HA proxy. Envoy is very popular at the moment in the cloud space. It is kind of at the moment service mesh all the things. Be careful. It's a new piece of tech, so your risk tolerance, what you're valuing in the company may not align with some of these things. But we're doing a whole bunch of work in DataWire on this, and I'm actually kind of really enjoying exploring this new tech. There is a hint with these kind of new technologies of things like enterprise service buses. Anyone who's worked in the industry 10, 15 years may have bumped into enterprise service buses, and they had some negative things associated with them. Typically, people put too much business logic into the bus. And the bus became connected or coupled with the application. So when they wanted to roll out new functionality, they had to roll out new code in the app and new code in the bus. And that was a nightmare to orchestrate. So if you are looking at things like service meshes, just be aware that you need to think about loose coupling in all you do. The infrastructure should not contain business logic. Whenever you see yourself adding sort of bits of business logic into your platform, that's generally a bad smell, bad sign. It does allow fine-grained release, which is what I want to talk about here. And there is many control planes. So Envoy is kind of like it's a proxy. We call it the data plane. It's the thing that does the heavy lifting, that routes the traffic and that does circuit breaking. Ambassador I work on, open source API gateway. Glue, a similar kind of product from Solo. There's Istio that handles more service-to-service comms. And Console from HashiCorp does this kind of space as well. So if you're interested in exploring what a service mesh can offer and how it would help you with canarying, definitely check out those links there. Again, shameless plug, I did a bit more talk on this at KubeCon, so if you want to dive into these kind of things, I talked with Nick Jackson from HashiCorp about the benefits of using these modern proxies at the edge of your system and also within the kind of inter-service communication stuff and how it can be used in various sort of ways as well. A couple of Canary gotchas for wrapping up and moving on. So you need to be able to understand your system. If you are going to incrementally roll out things and roll back when stuff goes wrong, you've got to define things like SLIs, like latency and throughput. You've got to then marry that up to service level objectives. You've got to understand what is a good sort of quality of service for you. And you also need some business metrics. I see many engineers that do canarying and be really obsessed about rolling things back if we see operationally bad things, but they don't always think about rolling things back if they see bad business metrics. The checkout value is lower, customers are walking away from your website. You need to factor this stuff in if you're going to start experimenting. You do need a high volume of traffic to get sort of like a realistic view of running a canary, and I'll give you some tips on that one in a minute. And do take care of side effects. I've seen a couple of people roll out canaries in production, and it causes inadvertent side effects because they've got two versions of their app in place. A classic one, actually, I saw someone roll out a Java service which did automatic DDL upgrades. So they rolled out the Canary. The Canary looked at the data store and went, oh, the database needs to be upgraded. It upgraded the database using Flyway, and all the main services fell over because the underlying schema in the database had changed. So you need to think about side effects of those kind of things, yeah? With sort of observability, focus on the golden signal. So you can Google this kind of term, but things like latency, traffic, errors, and saturation are really key from an operational standpoint. It is okay, I think, to just draw graphs. Don't worry about automating some of these things, but do create alerts. Like, you know, like as a business, if like, say, if your checkout value or your customer value is going down, you want to be alerted to that and you want to stop your experiments. Yeah, can't emphasize that enough. Do create alerts based on these things. You can do load tests with kind of synthetic traffic. If you haven't got enough real traffic, you can try to recreate traffic just to simulate canaries. There is some trade-offs there with that, to be honest. But that is one option. And I can go into more detail in a minute, or after the talk if you want to know more. I've done a bunch of things. I worked on an open source tool called Hoverfly for a while. If you're in the Java space, you've probably heard of WireMock, similar kind of thing, where you can basically create synthetic versions of your services. So you can minimize side effects. That's an option to explore as well. One observability thing I wanted to pull out is a lot of engineers I work with, and myself included, want to build like observability dashboards like this. Yeah, because it makes us kind of feel important, I think. It makes me feel important sometimes, which is kind of weird. But realistically, you just want super simple graphs and super simple commands. Yeah, so I have to rein myself in from building the kind of nuclear reactor thing there. Anyone who's seen Chernobyl, a great TV series going on at the moment, will know the nuclear reactor kind of UX is really important. The same with like the 3 Mile Island disaster as well. UX around being able for humans to build a mental model of what is going on in the system is really valuable. And I've learned a lot from that book I mentioned up front about thinking about UX of tools that we as engineers use. Right, I'm going to quickly skip over because of time. Obviously, a lot of things coming at you. This is meant to be a kind of primer talk to get you thinking about this space. So many times I've gone into companies, I've done this talk, I've gone to conferences, and I guarantee at least one person at the end of the talk comes up to me looking worried, saying, "We're building a platform." And it's like, and I'm not trying to scare people, but I'm trying to get you thinking about where to add value. Like, there's all this amazingly cool tech in the cloud native space. we arguably haven't caught up in terms of people skills and tooling to take advantage of all this cloud-native tech. That's kind of my pitch, really. So I talked about, like, we probably want some kind of centralized team, like providing platforms, providing self-service, being kind of subject matter experts in the platform. And we as engineers around the edge, we just build and test systems that add business value. We don't need to worry quite so much about the platform. Now, obviously, like, your company needs to be a certain scale before you have a couple of people in like the ops team or a couple of people in the platform team. So take this with a pinch of salt. But one of the things I wanted to kind of leave you with is some stuff like based on my very anecdotal consulting experience, but I've worked with a bunch of companies, and they generally fall into 3 categories. Companies that haven't really got product market fit, they're kind of new, some of them that are running stuff in production, and some of them are like running like high-value stuff that must not fall over. And this is kind of where I say, so if you're like in prototyping phase, do as much stuff locally as you can. Maybe use telepresence and Squash to do some remote debugging in clusters, things like that. And canarying is really valuable, like either with synthetic traffic or if you've got some early customers, like roll out new features gradually, see if the users enjoy those new features, see if they work. Guide rails, I say YOLO. You only live once. Yeah, don't worry about guide rails at this stage. Like, just make it easy to do the right thing. But you really want to focus on that inner development loop. So I, in the past, have used things like Maven archetypes, or I've used Yeoman to automatically generate skeleton projects for microservices that have hooks into all my systems. So I go into Jenkins, usually my team building this to be fair, but I go into Jenkins, I type in the name of my microservice, I press the button, and out pops a Git repo, and the Git repo contains code that's already linked into the CD pipeline, linked into Prometheus for observability. Make it easy to do the right thing and get up and running really fast. That's the key thing. If you're more in the production stage, I definitely think kind of like the hybrid, like testing, say, on like remote clusters, doing as much locally as you can is really quite valuable. But you definitely don't want to be doing like some of this stuff in production. You probably now want to be having staging environments if you can, these kind of things. Canarying is still really valuable for rolling out incremental changes to customers and seeing what they make of it. But you want to be investing more in pre-production testing. Because whatever you're canarying, you don't want it just to fall over straight away. Yeah, so you want to be investing a bit more in pre-prod testing. A few guide rails going in, make sure people can't delete the production database. I've done that a couple times. Yeah, you want to make some, are you sure on that kind of command, that thing? And focus on observability and scaffolding. So being able to understand your system, because if you're building an event-driven microservice system, it's sometimes just really hard to understand your system. That's why things like distributed tracing are quite useful, drawing graphs of your system using various tools that are out there. And again, codifying, really focusing on the scaffolding I mentioned, codifying best practices that we all share in the team and putting it into code, because that's the best place. Automate these things, because automation is much more reliable than us as humans. If you're in the mission-critical stage, I definitely think more and more stuff needs to be done locally, because again, you cannot risk rolling out stuff into prod that falls over straight away. A lot more pre-prod testing using things like service virtualization. Canarying is still valuable, but you've got to be careful on the side effects of your business. If you're rolling out something and 1% of your customers are having a bad experience, but that 1% of traffic is from your most valuable customer, that can be really damaging. So you need to think about these kind of things. You typically want more guide rails at this point. You want to be sort of, maybe like Nico offered, he offered an experience over the top of Kubernetes that constrained what the developers could do. And again, he worked closely with his developers to understand what they wanted, but there was the guide rails to stop people doing wrong things, and more importantly, making it easy to do the right thing. Yeah. And again, observability, debugging, and the ability to recreate, say, data, bearing in mind things like GDPR, you be careful recreating production data, but the ability to spin up kind of like little bits of your environment to do testing on, I found invaluable. Too many times in complex cloud-native systems, it's just really hard to figure out what's going wrong, and to be able to clone a bit of your system as a playground and poke and prod it without doing that in production is really valuable. And again, I'm kind of quoting Nicole Forsgren. Nicole mentioned this a lot. Like in enterprise systems, the ability to recreate systems is valuable in itself, because if a system blows up, you can recreate it, but it's super, super valuable for understanding systems too. And that is pretty much it. The conclusion, pretty much, the summary is what you saw up front. I really want to argue here, developer experience is really important, and the cloud does change this kind of dynamic a bit. I was quite happy doing Java, monoliths. I see the value of microservices 100%, but when I lost all my cool monolith tools and started working on microservices, there was definite friction there. I made some mistakes by building too much platform sometimes, by not thinking about where the value is being added, so you definitely need to think about how much platform you want to build. But you also intentionally must curate the experience. And you know your company better than I ever will, so you need to work as part of a team and saying, where are we weak, where are we strong, where do we want to do guide rails, where do we want to automate things, and there's many tools out there. The cloud native community is in general very welcoming. Hat tip to the Cloud Native Computing Foundation in that respect. So there's plenty of working groups you can chat to, Twitter groups, Slack chats. I say get involved and help drive the direction. Thanks for your time. Appreciate that.